Hello everyone. Today we're going to learn about derivatives of log function. Just a little bit more. I know you're already bored, but yeah, that's what we must do. Okay, so for example, we have this function. We want to derive b to the power of x. How? For example, so this is what this is just pembuktian. I'm not sure what is pembuktian in English, but yes, okay. How can we get this? Okay, let me show you in numbers. So this is the formula for the derivative of b to the power of x. The derivative of b to the power of x is b to the power of x ln b. Okay, let's see example here. Let's see, we want to find the derivative of 4 to the power of x. Okay, bear in mind, this is not the same with x to the power of 4. Okay, if x to the power of 4, what we will get? 4x to the power of 3. But no, this one and this one is not the same. So to do it, to solve this, first x brought to the front and 4x minus 1. Right. Okay, and this is also, I don't know. Okay, this is also wrong. This is not the way to solve it. Okay, whenever you found something like this, just remember this. Okay, so just write it back. So for the dx of 4 to the power of x is 4x ln 4. Okay, just remember the formula. Okay, so now we're moving on to derivatives of exponential function. Okay, just recap. Okay, is y equal to ln x is also equal to log exponential x. So this e here is the exponential function. Okay, now we're going to solve example 16. Okay, we start with number 1. Y equal to x to the power of e plus e to the power of x. Okay, wait. I think we show a few examples on how to solve the derivative of exponential function. Okay, let's see here. We have, this one not yet. Okay, this one not yet, later. Okay, this is another question, not in example 16. Okay, so we have y equal to e to the power of x. So how can we solve this? We just use this we just use this formula. Okay, so it should be EX ln E. Okay, and now we have Y e to the power of 3x. So what the dy dx for this should be, rewrite back the e 3x and then the derivative of the 3x here. The derivative of 3x. What is it? The derivative of 3x, you will get 3, right? So, final answer is this. 3e to the power of 3x. Okay. Can you understand, guys? Okay, so whenever you have to derive exponential function, you have to remember the dy dx of that's ex. So the dy dx of dx is also ex. Okay, but when you have a value here, okay, when you have a value here, you have to as I said earlier, the dy dx of ex is also ex. So write back, if you have e to the power of 3x, write again e to the power of 3x and derive whatever function on the top here. Okay, so when you derive 3x, you will get 3. So the final answer for this is 3e to the power of 3x. Okay, sorry, so why this is when you derive ex, you will get dy dx e to the power of x ln e. Okay, remember we are using the formula before, where b to the power of x equal to b ln b, right? So why is it? Ln e is equal to 1. So that is why. Okay. Okay, now we're going to solve question number 1. Sorry. X to the power of e plus e to the power of x. So the dy dx for this equation is, we try to calculate it one by one. So xe, the ddx of x to the power of e plus the ddx of e to the power of x. So for this one here, e brought to the front and x e minus 1. Okay, in this case here, just treat e like any number. Okay, and this one, the derivative of e to the power of x is also e to the power of x. So now we are going to write it nicely. So e over x minus 1, x to the power of minus 1 is also equal to 1 over x. So now we have e x e plus ex. Okay, this one, sorry, let me write this nicely. plus EX. Okay, so this is the final answer for question 1. Now moving on to question 2. Y equal to EX to the power X to the E to the power of X ln 3. So now, remember the dy dx of E whatever X is the same thing, write back the same thing, and then find the d dx of whatever on the top here. Okay, so whatever on the top here this time is X ln 3. Okay, so the I write it back again, EX ln 3. Remember when we solving the ln function, okay, ln can brought outside, right? Okay, ln 3 can brought outside, so now we just have to derive X. So derive X got 1. Final answer is EX, E to the power of X ln 3 times ln 3. So this is the final answer for question 2. Okay? Okay, so now we're going to solve question 3, which is y equal to E to the power of X ln X. Okay, looking at this equation, you can see that it is a multiplication of two functions. So whenever you see multiplication of two functions, which formula you should use? Remember? Okay, I just want you to refresh back. What is it before I wrote it down here? Okay, so we shall use the uv prime plus vu prime formula, which is the product rule. So u here is e to the power of x, u prime should be e to the power of x, and v is ln x, v prime is 1 over x. Okay, so dy dx is, I'll write it down again. Okay, uv prime plus vu prime. uv prime is ex to the power of x plus vu prime ln x times e to the power of x. Okay, so final answer should be, okay, this is the final answer. Okay, uv prime plus vu prime. Okay, now we're going to solve question number 4. Okay, question number 4 is y equal to e to the power of x ln x square plus 1. Okay, as with the other technique to solve exponential function, the exponential of e to the power of x is e to the power of x. Okay, and whatever function that attached with it. Okay, so ex ln x square plus 1 and multiply with the ddx of whatever function at the top here, which is, in this case, is x ln x square plus 1. Okay, looking at this equation, there is two functions here, right? One is x and the other is ln x square plus 1. So So now we shall use the product rule because this is the multiplication of two functions. So u is equal to x and u prime is 1. V is ln x square plus 1. V prime is 1 over x square plus 1 times with the ddx of x square plus 1. Right? Remember, this is the chain rule. So, final answer is 2x over x square plus 1. Okay, now we have solved this part here. I'm going to write it back. X ln x square plus 1 times with uv prime, which is x, times 2x over x square plus 1 plus vu prime, which is ln x square plus 1 times 1. Okay, write it back nicely. Two x square over x square plus 1 plus ln x square plus 1. And this is the final answer for question number 4. Okay? Okay, now we're going to solve question number 5. Question number 5 looks a bit tricky, but it is solvable. Okay, don't be afraid. Okay, now we have y equal to x plus x square plus 1 times with to the power of n. Okay, so the dy dx for this should be just treat n like any number. So n brought to the front and x plus third x square plus 1 to the power of n minus 1. Okay, don't forget the ddx of whatever function in the bracket. Chain rule, guys. Okay, so this should be x plus third x square plus 1. Okay, so now I'm just rewriting the first part here, and x plus third x square plus 1 to the power of n minus 1. So the ddx for this is what, guys? Okay, we're going to solve it here. So the ddx of x is 1, and then the ddx of third x square plus 1 is, okay, I think we should do it here. So as x square plus 1 is also equal to, right, x square plus 1 equal to the power of 1 over 2, right? Okay, then the ddx for this is, okay, half brought to the front and x square plus 1, and then we and this one should be half minus 1, you will get minus half, and the ddx of whatever function in the bracket is 2x, right? 2x. Okay, so half x square plus 1 minus to the power of minus half times with 2x. So 2 can be cancelled, Okay, remember, if it is to the power of minus 1, it is also equal to 1 over something, right? So this is x plus third x square plus 1. Why? Because this is minus 1 here, to the power of minus 1. Okay? Times with 1 plus x over third x square plus 1. Okay, so this is the final answer for question 5. So that concludes our lecture for derivatives of exponential function. Okay, bye guys.